Well, hi guys and girls, Emma again. Welcome back to the spare room. This is unapologetic new project, right? It's been in my mind for some time to do it, and it's sort of, I guess it's been going to happen for a little while, but maybe it's time to do it, maybe it's not. Maybe you won't see this video for a little while. But I've got this Stuart 800 engine. Some of the history of this, you've all been following this, I'm sure, and everyone knows that I've been building this. It's a 1920s Stuart design. The information is sketchy via Henry Greenlee's book. Not a lot of information there, and it's getting, it's getting closer to running. There's not many things that still need to be done to it. There's still a casting to make. Got a pattern sort of in the build. There's a gas valve to make and a muffler, a few things like that. But that's just to keep everyone up to speed. That's in the loop, I guess. If you want to follow this build, it's on Patreon, and that's pretty cool. And I thank anyone who is, because I really appreciate that. But that's the Stuart 400. Fairly big, fairly ambitious project that I've made. It's getting close to running. It's a fairly nice little engine. I think I really am a little bit impressed with the way that's come together, but it's not a lightweight by any means. But what I wanted to do for some time is to build a casting kit from Stuart from the same time period that was still available from the foundry and see how they compare. The logical and most cost-efficient way to do that is to order a box that looks like this from Stuart Models and get it and open it, and we'll unpack it and we'll have a bit of a look. This is the Stuart Progress, or one of the models in the Stuart Progress line. The Stuart Progress line was a very simple steam engine kit line in the 20s, 30s, 40s. There was a whole selections of engines that could be built with the same basic parts, the same cylinder, same flywheel, and some of the same bits. The one that Stuart Models have chosen to reproduce is this little oscillator, and it's not the first one that's been built on YouTube. There's another one Mr. Pete made, and it seems a fairly nice, fairly straightforward engine from the same time period with the same sort of drawings. And while we're in the mood to do 1920s model engineering projects, which is going to pass, I thought I'd have a look at this. So the kit's got a book in it. We unpack it. I've already had a bit of a look inside here a few months ago when it arrived. Stuart Models, of course, nowadays come in a cardboard box. It's marked Stuart Progress, set of castings on one end and the part number, Groveworks, West Road, Bridport. And that's what you get, is what I've always got in my lifetime from Stuart Models, is a vac form box of bits, which may or may not be as good as they used to be. I'm not sure. We probably won't go into that, but certainly from looking at this, the castings for this were not too shabby. We get sheet of gasket paper. We get some blue seal strip for lagging the cylinder. Have a look. We get a box bed, which is a fairly similar sort of design to this. It's got a couple of lugs on it to clamp it down, which are probably leftovers from the casting process. And it's really quite a lightweight cylinder, but it's not very, it's really quite a lightweight casting, but it's not very big. We get a tiny little flywheel with a piece sticking out to machine. It's quite a pretty little flywheel. I think that'll machine up nice if there's no hard spots in it. We get a box bed, we get a bed plate, which is also pretty tiny. It's not a huge big casting, but hopefully that machine's nice too. If we look at this as a 3/4 scale model here in the background of one of Stuart's bigger engines at the same time period, and this is probably one of their smaller ones. So interesting comparison there. What else we got? We got a cylinder, which has had some compromises for cost and because of the foundry probably. This isn't cored. The one in the book says that it was cored, and Stuart no longer core castings or core cylinders, it seems, but not this one anyway. We've got a couple of cylinder covers, front one and the back one, and a crank which bears a lot of resemblance to the crank on the Stuart 400. You can certainly see a family resemblance on a lot of these bits. There's a gland, it's bronze, and a piece of bronze probably for the piston. And some bits of silver steel which have been cut off with a angle grinder and still sharp on the ends. That's pretty poor. If anyone from Stuart Models ever watches this, that's really a bit rough. I'm going to go out there and say that. And there's some stock and a little box of parts. What do we got here? We've got some graphite yarn for packing, not a whole lot of it, but we've got a spring obviously for the cylinder, I think. Got a mounting bolt nut, I reckon, which looks like it's not particularly good quality nut, but looks like it's about 4BA. We've got a set screw, probably for the flywheel. We've got 4 brass screws, which are probably, I would add a guess, say for the cladding. 3 brass screws, could be for anything. We've got a quantity of hex head bolts. We've got what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 or something. What appear to be 7BA nuts and bolts, and one that looks like it's probably 6BA. So I'm not sure what that's for. I guess as we go on we will find out. So either there's bolts and nuts missing or that's all of them. What I guess we can do is find them as we go, if we change or mix up the plans or anything like that. So that's where we're at. Where do we start? We look at the book. It's quite a nice little stack of castings for the money, to be honest. The progress book, it shows basically all the progress engines, which were used a lot of the same bits, to be honest. Some of them we've never seen or you never ever see examples of. Some of them went on to become quite good engines, like the BB. And this book has instructions for everything. So theoretically, with a little bit of messing around and some more bits to make, we could turn these bits, or some of these bits, into any of these engines. But we're not going to do that. We're going to build this to the instructions as much as we can. So construction starts with the cylinder, according to this. That's what we got. As the cylinders and cylinder parts for this series of models are all more or less interchangeable, both oscillating cylinders being identical, and in the fixed cylinders engines, only difference between the Millinger has a longer bore is necessary to repeat the instructions. It's unnecessary to repeat the instructions in describing each model. The cylinders are supplied bored and face. No, they're not. That's something that Stuart stopped doing a long time ago. The cylinders are supplied bored and face, the bore being made dead true by reamering with a standard reamer. not much information about this, because of course it's already been done. So we have nothing really. And this is a problem that we were faced with on the 400, because interestingly the dimensions just weren't there. Looking at this one though, we've got enough information on these two drawings to give us the information. This says it needs to be 1.1 long. It probably needs to be 1/2 inch bore. There we go. And I guess finishing that up is the first thing really we need to do. That's pretty straightforward, and that at least get us up to speed. So ways to do this, there are numerous ways to do this. We could clamp it and face this end, and then clamp it on an angle plate and machine each end and bore it in the mill. Yeah, and all you had was a milling machine. We could do it in the lathe. We would do it in the 3-jaw nearly, because this needs to be on centre here. So all we've got to do is grip that in the 3-jaw chuck, face one end and bore it, or even better, clean it up a little bit and then bore it, and then we'll make a mandrel to bolt this on to machine. We'll face both ends, put it on an expanding mandrel, I think. So that's probably what I'm going to do, and then from there we might leave it on the expanding mandrel, and we might set it up in the mill and face this other side here and put some ports in it. So I think that's the first thing. So let's get in and do that. So first job on this little casting, I guess, this is what I've got. There's no real straight edges on it, and we can't really as such just grip it in the 3-jaw and bore it and face one end, because we haven't got anything at all to line it up on. And if it ends up not quite centered between this side and this side of the round piece, then you're going to end up with a bore that doesn't work particularly well. This should be pretty straightforward really to machine. I'm probably just going to set that up so that tool just touches there. We're going to go to that tool. It's probably not far out there, but just to check it, I might just run a Z-square or a little square here and just see how these look like they're lined up this way. I think it'll be right this way, and it doesn't matter much, but it needs to be lined up this way and this way. Theoretically, all this can be done in the lathe, I think, so whether we're going to do that or whether we're going to swap over to the mill at some point. And this square will be just the thing for this. That's pretty well lined up there, and that's pretty well lined up there. They're pretty well even. We're going to take this sprue off, just tighten that up a bit. And for first, I try not to get into politics of model engine making, and I've already said that once about this, but if you set something up to iSuite or to a point that it actually looks good, the gap's the same on both sides, you can go through all the complicated maths you like to get the result, or you can just rush in and not actually think about the consequences. But the reality is that if this casting is iSuite somewhere near, it looks like it's in the middle, it looks like it's balanced, you can't see too much wobble in it anywhere, it's probably going to be close enough to make a pretty nice run in a little engine. The exceptions are the alignment of the cylinder, the faces to the bore. But when you're first starting out on a casting, just a fairly basic casting, which is not all that exciting as far as castings go, this one, it's just ordinary lump of cast iron with some holes and shapes in it, you need to have a think about what it's going to look like and where it's going to be, and clean up one side for a reference, and then from there, even if you've got to set up a machine that side again, it's not going to matter anything. There will be those that will call it a comedy of errors, etc, 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 but the reality is that if you've got to do it twice, it's a home workshop, no one really cares. Probably if you've got a smaller lathe or a lesser lathe than this, or you're in a rush, sitting down with a hacksaw and cutting that screw off before you set it up would be a good idea. We want to keep a bit of an eye on there, because it's only rough casting and there's a parting line down the middle and it's got a bit of draft on here. We don't know much where that's going to be, but as you get closer you'll be able to see where it's cleaning up on this line, and if it's cleaning up nicely all the way around and the gap's pretty good all the way around it, you're not far out. And that's cleaned up beautifully. I'm going to take just one more little skid off there. Of course this isn't, it's nice to follow the drawing and to be scientific and etc, 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 but the reality is that if this dimension is even 1/8 of an inch taller than it needs to be, it's really not going to affect the engine at all, even a little bit. The cylinder's going to stick out a bit further. The crank pin's probably going to be a fraction longer. It's going to have a bit more clearance in it. Really doesn't matter. So that's cleaned that up nicely. Pretty happy with that. I'm not sure we're right on centre there. We might just lift the centre a little bit in that tool and run across it again, I think. If we have a look here, the dimension we've got is 19/32 from the centre. That's all I've got. Like I said, if this is 21/32 or even 23/32, it's not going to matter, and if it's only 18/32, it's not going to matter either, because this isn't going to touch here on the crank pin, and we can make this a little bit shorter or longer or whatever. So I'm probably just going to measure that with a ruler to the high point there of the cylinder, which is there. It looks to me to be about, we're going to go 32nd over 3/4 is, could be a whole lot shorter than that. We might set it up afterwards and do it again, I think, because we can't really measure off this. But we've got plenty there to work with, so that's all good. Just checking for that. Now we can drop this out of here. Like so. And that's looking pretty good. And we've got a square face here, a square with the cylinder. This has got to be right this way, and we can line this up with the chuck jaws. It's also got to be right this way, and now we've got this, we can line that up with the chuck jaws as well. So if we do this in the 4-jaw. Anyway, switched the mill to bore this. I thought, well, there's a few things we could do. We could do it on a faceplate, we could do it probably in the 4-jaw with a bit of messing around and some careful setting up. We could probably do it, certainly do it in a vertical mill fairly easily. We've got a reference surface which is down on the bottom of the vise here when we've set it down. I've set this on a couple of parallels between it, and that way I can center this between the parallels and get our center this way. Just with the wobbler, check this one and this one, find the center, and then I've measured this distance here, and if we find the top here, then we can go half that way down, and we should have the center of these two radiuses, which is what we want. And then we can drill it and bore it and ream it and face it and all those sort of things that we need to do. So to my mind, the first thing we really want to do is work out how long this casting is, which is 1.4, about 1.412, something like that. More importantly, we probably want to know what the distance between is. If we look in the book, we find a whole lot of disinformation, but the piston or the casting needs to be 1.8 inch. It's 1.4. So this wants to be balanced each side. You can have a dimension for this, but if you work all off one side, you're going to find that they're wrong. You really need to work off the center, and to do that, we'll find this distance here between these two cheeks, and we'll take that from 1.8 inch and halve that dimension, and that'll give us the thickness that this needs to be on this side. So pretty straightforward, really. We can get in here with internal micrometer, but it's a casting, so what are we looking at? That's about 800 there. 815 maybe. Let's go 815. If we put this in a calculator, 1.125 inches minus 0.815 is 0.31 of an inch, divided by 2 is 155 thou it needs to be. So if we can machine this down so that without touching your parallels that this is 155 thou from there to there, we're pretty much in the ballpark. And we've got a flat surface, and it's probably very easy if we needed to go across to the lathe then and bore this out, or we can do it with a mill. Probably I'd be inclined to do it in the lathe, but let's get this straight and parallel with this bottom one, and we're starting to look pretty good at it. There's no reason why you couldn't do all these operations in the milling machine, the same as there's really not much reason why you couldn't do it all in the lathe if you messed around with tooling and got everything looking pretty good. The smart way in a horizontal mill to clean this up would be to use a side and face cutter, about 4 inches diameter, and just run past the end of it. Pretty quick, easy, job's done, one pass. Really simple. And that'd be great. However, I'm not going to do that because I'll have to change the arbor over, and I'm going to want this machine set up like this in the very near future. So this should be our final cut through here. So back in the chuck again. I've just scripted on the other end here and sat that machine face down there. I've checked it all around with a square, and it all seems pretty good, nice and upright. So the thing would be to measure the machine at the length of 1.8 inch. That's pretty straightforward. And then drill it and bore, or drill it and ream it. So while it's nice to get this exactly the size, it's pretty much irrelevant because everything else in the ports is set up to the center, this way and this way off the center, on everything. Cylinder covers are off the center because the pivot holes in the center there. So it's pretty irrelevant how long it really is, as long as it's longer than the minimum dimension. Because as long as it's as long or longer than the minimum dimension, because a bit extra clearance on the end, if it's 1/16 of an inch, or if it's 10 thou, or if it's 20 thou, really isn't going to matter. Not going to matter at all. Your covers go on each end, your piston goes between them, it pivots in the center. If your pivot hole and your crank are in the right spot, nothing's going to touch. So the thing to do is to clean it up so it looks eye sweet. We can measure this very easily with a depth micrometer, so we're getting pretty close there. And that's probably as good a way as any to measure that, just off there. And it's within about 5-10 thou. And to be honest, no one's ever going to know if that's 20 thou out either way. That's within about a thou there. That's pretty jolly sweet each end. It's within about, what's important here is that casting looks like it's in the middle. So I'm going with that. It's probably a fraction long, but it's not going to matter very much. And this is the reality of working with castings on old drawings, is that where you end up is where you end up. And it's a matter of knowing which dimensions are actually important and which ones aren't. It's very easy to say all dimensions are important. You need to hit the line all the time, but if you do that, you're going to find that your casting is going to be out and it's going to look ugly, because nothing's going to be lined up in the middle. So from there we can drill it. It's a nice soft cast iron. Hit that with a centre drill. .6mm, and we might follow that through with a nice 12mm drill. And I've got a 12.5mm reamer, which will be close enough to 1/2 inch for me. You can rush out and buy the right reamer, or you could bore it without a lot of problems. I'm going to slow that down. And we're that far advanced. So, what's next? That's what we've got. Starting to get much lighter and much smaller than it was. It's got a pretty decent finish in there. It's not too bad. I've just broken a belt there, so I'm going to have to fix that tomorrow. We will make some filing buttons, one each side, to get this down to size each side, because this is a bit irregular here, and that'll give us something for the cladding to wrap around nicely. We'll probably give that a file up and a clean up. We need to get this down to, so that this diameter here, or this distance across here, is somewhere near. So quick easy job is just to set this up against a flat plate. Not much to it, very simple. We've already measured it. We know approximately how much needs to come off it. We know what needs to come off it, and we can touch off, and we can use our hand wheel here to cut that down to the right level, and we're done. Can't measure this, so I'm gonna machine some of this off. Not a bad idea to double check. Just lower that in there, make sure that that scrapes all the way around nicely. Looks pretty good to me. Turn the lathe off after changing the belt. And the measurement we need is 4.67 off there. We touch that up and zero the hand wheel. Might put some oil around this because we've got a nasty noisy bearing now. We've got a tight belt. We've got a noise in that belt. I don't know where. I think it'll come out of it eventually. We're just got to live with it. It's rubbing somewhere. It could be the main, it could be the shaft bearing up there. It needs a shim out of it, but we might live with that. Anyway, we could mark this and set it up again on centre very easily and drill these 3 holes. That's probably an easy way to do it with the 4-jaw. We could transfer it across the mill and find the centre and mark it that way. That's probably the more accurate way because we've got a DRO. I think the 3 holes, the pivot hole in the centre and the other 2 are the next thing on this, so I think we're going to go over the mill and do it. I've just used a piece of shim in there. If you have trouble holding everything to stop the marks on the ends, a bit of tape's good around it too, over the top of your shim. That holds everything in place. But there we go. Starting to look something like. I'm probably going to mark this down here to the right width and file this across here, I think, rather than leave this. The problem is that this casting isn't really the best casting for this. Unfortunately, whoever's designed this hasn't done a particularly good job because that's so much wider than that needs to be. So we could easily just take these off on an angle here and they would look pretty good. I think that would be easy, and it would be a lot easier to fit the cladding too with the screws in on an angle, maybe. Not sure about that. We'll see how we go. That goes on there like that. It's not a very big engine at all. But next thing's a pivot hole in the centre and 2 ports. So to set this up, left the parallel sticking up a bit on top here because they're not going to worry anything, and they're going to give us a surface to find the centre of this with. So that means that this flat surface can be parallel and flush with the jaws here, and we can set that up nice and square very easily with a 1-2-3 block or a parallel or something on the back. So the secret will be to find the centre here with the centre finder. Just move this until it kicks out like that. Zero the X. Go back the other way and do the same. And that's the centre. We'll find the side of this and we'll measure it, and we'll just go down halfway. And that's the side of that flange. Now, this is only rough casting. We did set that up to be on centre with this and this flange pretty close. So we're best, if you haven't measured that and had a good look at your casting, you're best to measure the thickness of the casting here. If we have a look in the book, 6BA is basic major diameter is 110 thou, which is 15 thou under the size of the 8th rod. If we put that in a collet and machine that and thread it, that won't be too bad. So I'm going to go with 6BA. Tapping drill for 6BA is 43, number 43. So change the collet, put a 43 drill in there. Drill it into the depth that's required. We're going to have a look at that and see what it is, and then we'll move each side. And according to the book, there's some 332 portholes. Very useful That's all we've got. 32 porthole on 13/16 centres. Doesn't say anything about high. I think they've got to meet up in the middle by the look of this cutout drawing here. I reckon we can do that. This is only about 8mm through, so we only really want to go in about 5mm with any of these. So the distance between the two holes on the two portholes need to be 13/32. Need to be 13/16 of an inch. Now, for those of us who don't still see the world in purely black and white, that's a difficult thing to work out. 13/16 is a crazy fraction, but we need a halfway mark because we've got to go halfway each side. So to have a 13/16 fraction, you double the bottom number. So 13/32 is half. This calculator is amazing, not sponsored, but that gives us a 406mm, 406 thousandths of an inch as 13/32. So all we need to do is move 406 that way and 406 that way and put two holes in. 406. We're going to go the same depth, so that's 1.5 turns. That's one turn. And around there to 62. We need to go back this way the same distance, and we're going to go the same distance in. Oops, there's no pressure. No, we haven't gone right through yet. And around here to 62 thou, which is halfway. It's also 1/16 of an inch. And winding back out. So that's the 3 portholes. I'm hoping I've got most of this footage that I've taken because my GoPro 8's playing up a little bit. So there we go. I've started this tap already. I'm going to finish him with a bottoming tap nicely and thread the piece in. Give him a rub on a piece of emery paper. We need to make some holes here that line up. Now, easy and a difficult way to do this. You could set him all up on a sign plate, sign bar, etc, etc, etc. You could turn this vise round, which is probably a really good way to do it. Turn this vise to the right angle once you work out the right angle. You could set it up in the vise on an angle plate or on an angle like so. And we probably put a parallel across the top to get this somewhere near right. They're not crazy long holes here, and they're not crazy long. I mean, this is fairly close here. They just needed, my fingernails are awful, sorry. Cast iron does that. Time for a clean up soon. But these need to be drilled, one there and one there. Probably we could still grip it by there, and we put it in the vise so we could turn the vise around at an angle. That's one way. So we're going handheld here, and I'll show you what I've done. I've set this up on a parallel each side. That's easy. And I've used a Z square and another little parallel here to keep everything nice. And I've set the flange down nicely or smoothly onto the bed of the vise. So what we've got is it's right this way. The angle's right because we've got a 30/60 Z square, which is in here, and it should be repeatable. So if we turn it around, we should get the same results on the other end. We can find our center here, and we could probably just plow into that with probably a 1/8, I reckon, a 1/8 end mill or a slot drill until it breaks through. So that's what I'm going to do there. I'll bit mess around and double check, triple check this setup and change to an end mill, and we might just run that in there. So we should nearly be able to see that. I don't know if you can, you can't really. It's a difficult thing to get into my field of view on the mill, and I try not to do that anyway because then I can't see anything. But this is the second side. We've got no row of light, or we've got this sitting down nice and solid on the mill. We've set this up with the Z-square nicely, and this is gripped on each side exactly the same as the other one, and we haven't moved the mill, so we're just going to feed that in. Until it breaks through. And it's probably way too far on that one, but it won't matter a lot. And if we have a look here, we've got a port there and we've got a port there, and they meet up with those two holes. So that's that done. We can go ahead and make a pin here, which is basically just a steel pin with a 6BA thread on one end to go in against the shoulder there, and a 5BA thread on the other one for the nuts. Really all that's got to be done to this casting now, I think, is to put the holes in for the bolts. I'm going to drill through the, rather than try and set this up, I'll probably do the heads or the caps in the dividing head, and then I'll probably just spot these through and drill them in the drill press and tap them. That's easy as anything. Quick, easy job. You could also set this up for coordinates and the DRO and set coordinates off the, find the center and set the coordinates. But that's a bit more messing around. I don't think it's anywhere near justified. So I'm going to make the covers and clamp it in place, spot drill one. I'm going to make the covers with tapping drill size holes in them, clamp it in place, spot drill one, take the cover off, drill that out to clearance size in that particular hole, and tap this hole and bolt it on then, and then we can go ahead and we can do the rest, a couple at a time or whatever. And once you've got them all in, you just put the screws in there. It's a slow way to do it, but it's good and easy and reliable. I did remember there was another operation. This needs to be recessed out in the back. I've gone ahead and done that quickly. If we have a look, it's got a recess here. It says around the pivot. No actual dimensions. It's got to match the body there. So I've sort of guessed this, because doing this with maths and science and trig isn't the answer, and worrying about it isn't the answer either. You just got to get in and do it and hope it's sweet when you're done. Clean it out with a file if it's not. So I've just machined a groove in there in the center, which was a fairly easy job, just with a slot drill like that. So that's the cylinder, pretty much up to the level we can do without making some other parts. We can't make a pin when we look at it. I'm thinking we probably could. Can't make that because we don't know how long it is, and there's no actual dimensions in the book. So we've got a groove in the middle. We've got the ports in. We've got the cylinder board. We've got both ends faced. What else has got to be done to it? We need to make a filing button to go on the end to machine to file these round. Probably one for each end, and clamp it up. We just hit it with a file or on the linisher if we've got hard buttons, and clean that up nice. That's quick and easy. The hardest part of doing that nicely is to make the buttons, and they're not even a big hardship. We need to make some covers then, and one's just a plain cover to go on one end, one bolts on with a screw down gland with 2 bolts in it. And then we can make the piston and conrod, and start looking at this casting here, which is pretty ugly. But if we clean some of this up, just hit it on the menisher and give it a good clean up, it's going to look a whole lot nicer very quickly, I think. So that's going to do for this time. Hope you enjoy this series. I'm going to put a bit of a list of, well, I'm just going to put times into this. So far in this we're about 4 hours, 4.5 hours machining that. It was pretty quick. It might have been a bit quicker if I hadn't been setting up cameras and things like that, messing around waiting for batteries and things like that. It's about 4 hours over a day and a half. And it's starting to look like a steam engine. So next job, so in the next video we'll get on and we'll make some more parts for that. Probably these two parts are very, very easy to machine. And probably the bend plate's very easy to machine too if we needed to. But we'll leave that for a bit. And next video we'll make these. Anyway, thanks for watching. Don't forget to like and subscribe. Check out my Patreon if you want to look at my Stuart 400 build. And probably there'll be some information about the next one as well. And be kind to each other.